Alright, thank you again. Without wasting any time, let's go to an example that is based on motions in physical science or engineering science. As you can see on the screen that we have an equation, v equals to 6 plus 2t, which represents the motion of a motorbike that accelerates on the road. Below this, we have questions asked with relations to the statement given. Then, the first question says, what is the initial velocity of the motorbike? The second one says, what is the acceleration of the motorbike? And then the third one, which is the last question, says, what is the final velocity of the motorbike after 2 seconds? Now, when we answer the first question asked about initial velocity of the bike, we just need to check the format of the given equation. And when we are looking at this equation, we can realize that this equation is one of the equations of the motion that we usually deal with in physical science and engineering science. And now, one of the equation that is given to us now is the one that is in the format of v equals to u plus at, whereby v symbolizes final velocity, u symbolizes initial velocity, a symbolizes acceleration, and t symbolizes time. So as u symbolizes initial velocity, we just have to check the number which substituted u in our equation there. When you check in the given equation there, you will see that 6 is on the space of u in our equation. This means that u equals to 6. In fact, u, which is our initial velocity, equals to 6 meters per second. Let's go to the next question, which says, what is an acceleration of a bike? Then here we just have to apply the same method we did in the last question we were answering. We know that acceleration is symbolized by a. Therefore, we must check the number which is substituted a from our given equation. When you check, you will see that the number on the position of a is 2 in that given equation, right? Now, this implies that a equals to 2 meters per second. That is our acceleration. Tackling the last question, which requires us to get the final velocity of the bike after 2 minutes. In order to get the correct answer here, you need to substitute t in our equation by 2, as it has been mentioned in the statement that it's in 2 minutes. Remember, t means time, represents time. But remember that the SI unit for t is not minutes, it's second. In fact, we have to convert 2 minutes to seconds first. And when we convert 2 minutes to seconds, we just multiply 2 by 16. We get that those seconds are 120 seconds. Therefore, we must changingly substitute t by 120 seconds and do the calculation to get the value of the final velocity. The situation will be like this in the new equation, where after substituting t is going to be v equals to 6 plus 2 into 120, or v equals to 6 plus 2 times 120. And then when you do calculation correctly there, you will find that the value of v at the final stage equals to 246 meters per second. This is the final velocity required from us to get. Alright, here is the task to be done by you under this chapter. The task there reads as, a car accelerates from rest to 20 meters per second in 6 seconds. To cover the displacement of 100 meters, and it is observed that the mass of the car is 550 kg. Now you've got the questions down there or instructions down there asking you or instructing you to calculate the weight of the car. That's the first one. The second one says the resultant force that caused the car to accelerate. That's the second one. The third one, it needs kinetic energy of the car in 3 seconds. The fourth one, it needs work done by the car in 6 seconds. Now, if you did your calculations correctly, your answers must be as follows. Answer for number 1, which is the weight of the car, must be 5390 newtons, which is 5,390 newtons. And then second answer for the resultant force, it must be 1833, which is 1,833 newtons. Now, the answer for question number 3 must be 27.5 kilonewtons, which is the kinetic energy. And then the fourth answer for the fourth question must be 183 kilonewtons, which is the work done by the car.